Before we start with your notes, can you answer this question? What do I multiply 1/2 by so that it would equal to 1? Or 2 over 1, because that would equal to 2 on the top and 2 on the bottom, and that would be equal to 1. What am I going to need to multiply 3/4 by so it will be equal to 1? Let me remind you that when you multiply fractions, you multiply top times top and bottom times bottom, and then the 12 over 12 would reduce to 1. What would you multiply 5/8 by so that it would equal to 1? What? 8 over 5. To multiply, you multiply numerator times numerator and denominator times denominator, and 40 over 40 is equal to 1. What do you call this kind of fraction? This is the reciprocal. What do I need to do to make a reciprocal? What? Flip. 8 on bottom, 8 on top. 5 on top, 5 on bottom. The reciprocal is the fraction flipped upside down. Okay, now that we know about reciprocals, now we can start on our notes. This is what we were doing the other day on that blue homework paper. We're going to use that in solving equations. On the blue homework paper, we change from one thing to another. Does that solve anything? When we were doing that on the other paper, we weren't solving it, we were just changing it from one form to another, and that's going to help us solve it. Once again, what is the first word in the first step? Isolate. This time we're going to isolate the term with the exponent, and that's usually going to have a parentheses around it. Then we are going to identify the reciprocal, raise both sides to the reciprocal, solve, and then what's step number 5? Mandatory. What does mandatory mean? You have to do it. It is not optional. Okay, so here we have a equation. This is the part with the exponent. Is it isolated? Yeah, it's isolated. So we need to raise this to the reciprocal power. Not multiply it, raise it to the power. What's the reciprocal of 4 over 3? And this is going to be 3 over 4. And so this will be 12 over 12. Because you multiply numerator times numerator and denominator times denominator. And this is going to be 16 raised to the 3/4 power. And the reason I wrote it that way is that's how you're going to put it in your calculator. And so this is going to be x to the first power, and you're going to put that in your calculator. It is very important, if you have a fraction exponent, you must put parentheses around the fraction when you're putting it into the calculator. So that's going to raise 16 to the 3rd power and then take the 4th root of it. So what's the answer? So aren't you glad that the calculator is helping you raise 16 to the 3rd power and then taking the 4th root of it, so that you didn't have to do the birthday cake on all of that stuff? And what is mandatory? Now, some people were having more trouble with the check than they were with the original problem. And so this is what we're going to check, and in place of the x, we put the 8. Now, in this step right here, is there any x that you're solving for? Because the 8 took the place of the x. You are not solving this. You are putting this into your calculator and seeing if it is equal to 16, yes or no. And so some people were doing all kinds of strange things with their check. And so is that equal to 16? It should be. And in order to check it correctly, this has to have a parentheses around the 4/3, and then you should get 16 equals 16. And so what does that mean? It means this number right here is a solution. Is there an extraneous answer? No. What is the first word in the first step? Isolate. This part needs to be isolated. What am I going to do with the 6? So this is going to be 3x to the 1/2 power equals -6. Now, I have made a mistake in what I wrote. Do you see what my mistake is? There was a parentheses around the 3x. Does the parentheses make any difference? Yes. Without the parentheses, the only thing I'm raising to the 1/2 power is the x. That's not what this problem said. This problem said the 3x is raised to the 1/2 power. Now, a 1/2 power is the same as a square root. But if I just don't necessarily, if I change it to a square root, have I solved it? No. You can solve it in either form, whether you have the fraction form or the square root form. I have to get rid of the 1/2, or I have to get rid of the root. Either way, it's the same thing. I am going to square both sides. Now, you don't have to do it both ways. What I'm pointing out here is either way you do that, you will get the same answer. So this is going to be 3x equal to what? Positive 36 or negative 36? This will be a positive 36, divide by 3, and x is equal to 12. And so I'm going to go back in my notes and put an or in here. You don't have to do this both ways. Either way you do this, you would come out with the same answer. And then I need to check. In the original problem, 3 times 12 raised to the 1/2 power plus 6, is that equal to 0? You would put 3 times 12 raised to the 1/2 power plus 6. You would put this part in your calculator and see if it's equal to 0. You must have parentheses around the 1/2 or you will not get the right answer. And I believe that would come out to be 12. Is that true? 12 is equal to 0? I don't think so. So what does that mean? This is extraneous. So what's the solution? No solution. You have to write no solution so that I know, that you know if it's extraneous and there's not another choice, then there is no solution to this problem. Now, this one, it doesn't have a fraction exponent. So we're going to use that rule that we had from the other day, and we're going to change it from radical form to exponent form. And so just to help you remember, the index is 2, and so this is going to be x minus 2 to the 3/2 power. The index becomes the denominator on the fraction exponent. Remember doing those problems before? We just changed it from one form to another. When you change it from one form to another, does it solve anything? Not yet. To solve it, I have to raise both sides to the reciprocal power. And so that's going to cancel out the 3's, cancel out the 2's, and that's going to be x minus 2 on this side. And you can put that one in your calculator. When you put it in the calculator, you must have a parentheses around the 2/3. And so that's going to be equal to 4. Does your calculator tell you 4? Add 2 to both sides. X equals 6. Check. 6 minus 2 raised to the 3rd power, does that equal to 8? You can put the square root in your calculator. That is going to be true. So what does that mean? This is a solution. Do we have any extraneous answers? What is the first word in the first step? Isolate. This part right here needs to be isolated. See that 12 in front? Is that 12 add, subtract, multiplied, or divided to the parentheses? It's multiplied to the parentheses, so the opposite of multiply is divide. Cancel, cancel. The reciprocal of 1 over 5 is 5 over 1. 5 over 1 is the same thing as a 5. The powers cancel each other out. 2 to the 5th power is 32. Add 1. Divide by 3. And check. You have to check with the original problem before I did anything to it. And I've written it down as you would put it in your calculator. 12 times parentheses 3 times 11 minus 1 close parentheses raised to the parentheses 1/5 power. Is that equal to 24? That comes out to be true. Did you put that in your calculator and see if you really do get 24? And so this over here is the 11 is the solution because that was true. this needs to be isolated. It is isolated. So I'm going to go ahead and raise it to the reciprocal power. What's the reciprocal of 1 over 2? 2 over 1. So I'm going to raise this to the second power. And that's going to cancel out the powers. See this number right here? This number right here makes this x squared. If this x is squared, this is a quadratic. The reason that's important is if it's a quadratic, you're going to solve by factoring. If you're going to solve by factoring, it has to be equal to 0. So I am going to subtract this from both sides and make it equal to 0. Now, the other day when we had an example where we had to solve it by factoring, once I showed you solve by factoring, some people were trying to factor everything. Why didn't I factor problems 1 through 4? Did I factor on problems 1 through 4? Why not? Was there an x squared? If there's not an x squared, then you don't factor. In this step right here, is there an x squared? Right here. You see an x squared? That's why I factor. You factor when you have an x squared that you're trying to solve for. And hopefully you had some practice on factoring on Friday, and show the factors of negative 12 are 1 and negative 12 and 2 and negative 6 and 3 and negative 4. And so which one of those pairs are going to add up to equal negative 1? Does that mean that is the answer? No, those are the factors. Those are not the answer. This is x plus 3, x minus 4. And so then you have to solve those equations. I would expect some of you could skip a few of these steps, but make sure that you do not make a sign mistake. Those are my 2 possible answers. Now, is it clear why I factored on this one and I did not factor on problems 1 through 4? The factoring is because right here in this step, x is squared. In those other problems, I didn't have an x squared. So we need to check. So, negative 3 plus 12 raised to the 1/2 power, is that equal to negative 3? So that would be positive 3 equals to negative 3. That is false. You have to have the same number with the same sign. So I have a positive 4 plus 12 raised to the 1/2 power. Is that equal to 4? Put this in your calculator to check it. Do you know the decimal that's equal to 1/2? 0.5. So you can use a 0.5 in the calculator if it's actually a little bit easier to use a 0.5 instead of a 12. But if you put that in your calculator, you get 4 equals 4. That's true. That means this one is a solution and this one is extraneous. The first word in the first step is isolate. This part right here needs to be by itself. What are you going to do with the 5? So this is going to be 3x plus 13 raised to the 1/2 power equals x plus 5. What do you do to get rid of a 1/2 power? Square both sides. These powers cancel each other out. And I have x plus 5. Is that going to be equal to x squared plus 25? What do you have to do with this part right here? Now, hopefully, some of you have done so many box problems, you're starting to be able to do this part in your head. And so if you can do this part in your head without a box problem, that's perfectly okay if you can do that without a sign mistake. A box problem is simply a way to organize it so you don't miss anything. If you can multiply it without a box problem, that's okay. Now, what do I see right here? X squared. So I need to factor it. So I need to zero out the side that does not have the x squared. Some of you also zeroed out the wrong side. When you zero this side out, you want the x squared to be positive because it's very hard to factor if the x squared is negative. Now, we did the factors of 12 on the previous problem, and the 3 and the 4 are going to add up to get the 7. And so x plus 3 equals 0, x plus 4 equals 0. When I solve it, I get my two answers. If I have two answers, I have two checks. Go back to the original problem to check. Plus 13 raised to the 1/2 power, subtract 5, is that equal to -3? In place of the x on this side and on that side, in place of the x, I put in a -3. So this would be, put all of this in your calculator. Remember that if you use a 1/2, you have to put a parenthesis around it. So this is true. So this is a solution. So check the next one. 3 times -4 plus 13 raised to the 1/2 power minus 5 equals -4. Put all of this in the calculator. Remember to put a parenthesis around the 1/2. So do I have any extraneous answers here? Both of those answers were solutions. There are no extraneous solutions.